Hi, this is Ben. Here's a really quick and dirty look at some of the issues around panorama vision and trying to design something to better understand what's going on. So a quick recap. When the left and the right eye look at something, so in this case the left eye sees the arrows pointing to the left, the right eye sees the arrows pointing to the right in blue inside a VR headset, the brain tries to fuse the two images into one. And for most people that's kind of what it'll look like, they'll overlap. With amblyopia, one eye will normally dominate. Okay, so either you'll see the arrows pointing right or the arrows pointing left, whatever it is that you're looking at. Turns out this is generally or often not the case with people who have alternating strabismus, where the eye that's suppressed can change at will. Somehow, their brain has got used to the fact that both eyes are looking in slightly different directions, and it lets them see with both eyes, zoom out a tiny bit, lets you see with both eyes at the same time. Very interesting. That means that there's only a smaller area, there might be this large or larger or even larger, where there's actually conflict. And then what does the brain do? Well, it seems in some people it maps that conflict area entirely to one eye. In this case, the right eye just dominates the left eye in that area, but the left eye still sees what's outside the conflict zone, or to the other eye, so the other way around. But what we've also seen is that non-interleaved areas are also possible. So that means that, like here, yellow, 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 with the left eye, suddenly a column seen by the right eye, then a column seen by the left eye, a column seen by the right eye, a column seen by the left eye, and then right, right, right. Wow, yeah, incredible. And at no point are any double overlapping triangles seen, okay? So this is sort of a regional suppression where the brain is selecting regions for one eye to see or the other eye to see. And we need to explore in more detail what's possible here, what happens, how the brain works. So here's a concrete example from Cliff where this is the pattern that he saw in a much, much earlier experiment. You know, one column with the left eye, three with the right eye, this strange interleaved mixture in one column and then the reverse on the other side. Very, very interesting. The thing is, it's hard to report what you're seeing. So how can we get concrete answers to what the person's perceiving in the mind? I've had people try and draw it on a piece of paper. It doesn't work very well. I've had people try and explain it. It doesn't work very well. But, you know, this hasn't been the focus. This panorama vision hasn't been the focus. So I've never really literally focused on this problem. But this is now the time, I think, to start looking more closely. So one thing we could do is we could have grid markers. So with the left eye at the top and the left, with the right eye at the right and the bottom. So when there's overlap or fusion or whatever, they're not conflicting with each other. Okay, they're independent in position. And that means if you see something like this, perhaps you can report, yeah, I see the yellow arrows or the arrows pointing left in columns A to D and from numbers 1 to 7, and I see with the right eye blue arrows contiguous from B to F in, again, all rows. So you see here, they're not seeing E and F with the left eye, and we discover the first column's been chopped off in their right field of view. The A column is missing for the blue. It gets more complicated as soon as you get this interleaving, but it's still doable, right? So, you know, they can look and report, I see columns A to D from rows 1 to 4 as yellow pointing left, and B to F in rows 1 to 4 blue pointing right, and then A to F rows 5 to 7 pointing right blue, and rows A to C, columns A to C, rows 5 to 7 pointing left, and I get confused even just looking at this. But this also assumes that, you know, you can actually see these headers, read these headers. One cool thing is we could replace these arrows with colours, patterns, high contrast objects, low contrast objects, animated objects, all sorts of things become possible, and the grid idea stays the same for reporting what you're seeing. Fine. The downside is, and we don't know the answer to this yet, is that it's not necessarily the case that the eye alignment is going to obey this grid layout. These things might be swimming, they might be moving. We don't know. We need to try this out now. Another idea would be, can we make an unambiguous design and a set of rules so that you can do something like drop a ball and play a game? Let's get back to this thing that Mr. C saw. So what if the rules are, if you see an arrow pointing left, so let's say, drop a pink ball in this column. Okay, so it's sort of visualized there in that eye. If you see an arrow going left, it goes diagonally left. So there's an arrow going left, it goes diagonally left. It goes diagonally left again. Now there's an arrow pointing right, so it goes diagonally to the right. There's an arrow pointing left, it goes left, and then it drops out. So the person can report the column that the ball drops out of, given its starting position. The trouble is, this simple rule set isn't ambiguous. It could have started from this column, or it could have started from this column, and they both end up in the same place. If it had started here, it would have ended up somewhere different. Now, for any mathematicians that are watching, is there an unambiguous design or rule set, given that in any possible overlapping situation, there will always be a unique output given that the ball drops in a particular column, so that we can trace back from the output they report. So all they have to say is, well, I've thought about, I've followed this rule and I've thought about where the ball would drop, because we might draw these as pipes instead of triangles, that's the other thing, presentation. So they can just say, it is going to drop out at this location. And that would allow us to unambiguously retrace what they must have seen. And by asking several times to build up an unambiguous picture of what it is they were perceiving. I don't know if that's better, faster, slower, easier, hard to say. Yeah? But it's another idea. Other things that we should explore after this, conscious and subconscious stimulus. What happens if, for example, in the right eye, where the brain is perceiving the left eye input, we suddenly show something that causes a subconscious attention process to kick off, like classic, yellow, black stripes rapidly moving towards you, or like a poisonous, like a bee that's about to sting you, or a snake that's jumping out of the grass. Things that you've evolved over hundreds of millions of years to have a rapid subconscious reaction to, or to shift your awareness to. Does that suddenly then switch into the other eye's awareness? What happens if we have, something walking across the screen from one eye, coming into the other's field? What happens? Do portions flip over? What happens if we stretch or scale or rotate or shift these regions dynamically? How does that affect the assignment of these areas? What if all of these units aren't the same? What if every single one is an icon that has a different picture? So you can actually identify by describing, there might be less of them then, but you can literally describe the order of these icons, these individual icons, so that it's easier to report when they suddenly switch from eye to eye. Yeah? What happens if we alternate? So we use the alternating scene I've already built, where we change, we show it in one eye, then the other eye, and we can change the frequency with which we show them in each eye. What happens if we ramp up the frequency, and what happens if we ramp it back down again? Does it settle in the same position every time? Does it settle in new positions? I think there's a basic need here, a fundamental need to create some environments to just explore what happens in your mind if you have alternating strabismus, if you have this panorama effect. What happens for you? And those environments have to be designed in a way that you're able to report what's happened, so you can note it, because it's in your head, it's a perception. There's got to be an easy way for you to get what you see out of your head and onto paper, so we can start looking for similarities between people and differences between people. We can start understanding what the range of possible perceptions are. And if we don't do this, if we don't start doing more of this, we aren't going to be able to design solutions that work specifically for people with this alternating strabismus where they can consciously fix on their eye. I think we've got to get behind this because we've noticed that the classic binocular suppression test for setting the luminance ratio just doesn't really work because it doesn't behave like it does for people who don't have this alternating strabismus. But we need to set a suppression ratio, otherwise the misalignment stuff doesn't work. So we've got to get a deeper understanding of this, and along the way I think we will maybe make some very interesting discoveries about how attention processes work consciously and subconsciously. So yeah, if this interests you, if you have alternating strabismus and you consciously fix your eye, and you want to put together some designs, literally just make some PNGs, yeah? 2 PNGs, we can pop them into the framework pretty quickly and make a build so that you can play with it, and we can share that between people with this similar panorama vision and start to collect real human experience of what they're perceiving, because it's what you are perceiving that matters. Cheers!